Hey guys, welcome back to my series on getting started with servicing, restoring early black and white televisions. When we last left off, we located some good service info. I have the chassis up on the workbench. I'm itching to dive right into it. I bet some of you are too. But I am creating the series as an introduction, a beginner's guide. So let's take a step back a little bit and talk about tools you might need, tools I recommend, and some safety issues. Now, from what I read online, and I've heard from folks, some are wary of getting into working on tube electronics, and TVs in particular, because of safety concerns. So let's address some of them. First off, we are dealing with glass and metal, so there is a potential for getting hurt by broken glass, by sharp metal edges, and so on. So take some practical concerns. These tubes are made out of glass, rather thin glass, vacuum inside. If you break one, it pops like a light bulb. There's an inrush of air, you hear a pop sound, and little bits of glass will, I was going to say go flying. It's not quite that dramatic, but yeah, there are some little sharp bits of glass that are going to break away. So eye protection, not a bad idea. Gloves, also not a bad idea. Might want to wear shoes rather than stocking feet or barefoot while you're working on this stuff. And ideally, you don't break a tube. Be gentle with them. I have a carpeted surface underneath my workbench, so if I drop something, they tend to not break, which is a luxury. You might want to put some padding down on your work surface. I have some carpet scraps I sometimes use and put underneath what I'm working on. Again, if something falls, it won't break. Also protects the workbench surface as you slide stuff around. Also protects the item you're working on from getting scratched up as you move it around. The picture tube, though, is really the one that you want to be the most careful of. It's the largest piece of glass by far. If these break, there is a potential for some rather large, sharp pieces of glass to get thrown out. So what happens is we have tons of atmospheric pressure pushing down on this. That's why they made these round. A round surface is naturally the most able to resist that force. That's why the early picture tubes were round. Square picture tubes present more surface area, more of a challenge to keep the air out. So what happens is if these fail, air pushes down on it, all the glass goes in on itself and then can ricochet back outwards. This glass is considerably thicker than what's on the neck. This is where it's most likely to break, which is a good thing, because if the glass breaks here, this tends to stay intact. In fact, my experience has been that it will remain intact. This is maybe 1/4 inch, 3/8 of an inch thick. The glass on the neck is significantly thinner. It's also more susceptible to being breaking because it's sticking out. We have a base sticking out here. It's about this long, so we have this long, thin, fragile tube running down through all this stuff. If this gets bumped, this will rack, and it will bump into this stuff and snap the neck. Or create a small crack in it, and air will hiss and go in. Again, that'd be your best case scenario because it won't implode. Glass won't go flying. You just hear a hiss, and your picture tube is shot. So you might be thinking, let's take it off. Let's get it out of the way. Let's remove the risk. Okay, yeah, we can talk about that. It's a little tricky to get out, though. We'll get back to that later. The tubes I'd mentioned earlier I tend to leave them in while I'm working on the set, but if you want to remove them because you're worried about them getting damaged, bumping into them, maybe you want to test them as well, you can remove them. I do it by slowly rotating. Ideal, grab the base, not the glass. There's an adhesive between these two, it can loosen up. Likewise on the base on the CRT. In fact, this one is loose. I've never had it happen, but theoretically if you yank on this you could rip this off. So if you can, slowly start rocking them like that. You might want to use a small flat-bladed screwdriver if a tube is really stubborn to get in there, and very carefully pry up. These bases are Bakelite, they're a little bit fragile. I've seen them where there's a center keyway here that locks it in when you're into the correct position. Those can break off. So treat them with a little bit of TLC. Let's see, we have an original Admiral tube in here. Generally, when I work on sets like this, if the CRT is tightly strapped down, I leave everything on it. Because removing it, it's a little bit of a hassle, and you're going to have to put it all back together too. Now when I got this, the strap had slipped off. It's still not that tight. It's also very frayed. Now I know why I saw these fibers inside the cabinet. Might have been a critter chewing on that. You might want to replace it. This is just a canvas strap. Nylon would probably work pretty good too. You want to use something that's not going to stretch. You can loosen these up, pull down the strap tight, tighten these down, and it'll cinch it down even more. If this is very tightly secured, and you tip this on its side to work on, put this side down because this is a large surface area, you should be okay. But if you do want to remove it, one, discharge it like we talked about in previous segment. Discharge it through a resistor, ideally. I'll rig something up for you. Now the easiest way is if you have a high voltage probe, clip the ground onto the chassis, put it on this, and if there's any charge you can actually read the charge and it'll bleed off while you're measuring it. Especially with the earlier type that have an analog meter built into it, because the meter is being powered by whatever energy is left in the CRT. This is a higher impedance device. It hooks up to a digital meter. It'll take a while to drain it off, but at least you can see what voltage is there, if any. More DIY approaches. Take some alligator clips, 470K resistor, clip the ground, resistor, another alligator clip, screwdriver with an insulated handle, clip this onto the metal, and discharge. There shouldn't be a spark, not if you're using a resistor of half a meg or a meg. And hold this on there for a minute or so, and you should be fine. Just don't hold the charge for forever. This hasn't been turned on in years. There shouldn't be any charge. Anyways, okay. So how do we get this off? One, we need to loosen this up, and then we need to carefully slide it out the front through all of this stuff on the back. We need to remove this base. We're going to need to do that anyways because we want to test this. This base is very loose. Be very careful. This is a nice socket, and then it has a hole in the middle, and the base sticks out, so I can put my thumb in there and pull this off. Now I need to wrap some tape around this to secure it. We'll be gluing it down more securely later. Now, probably the biggest hassle is there's this thing attached here. This is an ion trap magnet. These early types typically use a dual ion trap magnet, 12LP4, 10BB4. They have two magnets. You need to get this off. However, it needs to be in a certain position for this to work right. Usually when you find a set, it's in the correct position, as is. So take some reference photos, take a permanent marker, put a mark on the glass, you can see where it goes. You'll save yourself a little bit of hassle. If you don't, you can certainly adjust this later on and find the sweet spot. But if you need to take it off, the two thumb screws on this type, you loosen it up until it's very loose on there. Carefully slide it off. You don't want to rip this loose base off the CRT. And we should be able to go out the front. Now we have an electromagnet here for the focus coil. We have a yoke here. We need to navigate this base through that without this lip getting hung up on any of this stuff, which will rip it off. This is why I tend to not remove them if I don't have to. Final potential problem is up front. There are rubber pads here and here. Over time, these can melt and really stick to the glass. If they are, try rocking this a little bit. Get a paint scraper, some type of large, flat, somewhat flexible tool to get in there and try to break it loose. If you need to, even use a razor blade. Just be careful, as always, around glass. Don't scratch the glass. Don't put pressure. Do not put a screwdriver under there and start cranking on it. All right. I'm going to leave this on for the time being, although I am a little wary of the straps on either side, but I think I do have one or two new old stock ones around. There's enough left. I feel okay about that. All right, some other concerns. Notice I don't have gloves on. I notice more and more folks that work on vintage restorations wear gloves. I don't like to. I can't stand the way they feel. However, in the interest of safety, I have to point out, this is cadmium plated. Virtually every chassis, steel chassis you're going to find, 30s, 40s, 50s, is going to be cadmium plated to prevent corrosion. It's a heavy metal. It's toxic. As far as I know, from what I've read, it does not absorb through the skin, certainly not readily. Me doing this is really not a concern. When it's a bigger concern is if you were to take some steel wool or a scrub brush to this to clean it up, getting that stuff airborne and breathing it in, ingesting it. If your hands were filthy with cadmium oxide and you ate a sandwich or something, not the greatest idea. Other than that, yeah, there's lead in the solder. Again, unless you eat the stuff, really not a concern. There are no PCB containing components in this. There is no asbestos, and not in this model. So really, that's the only real concern I have to share with you, is this is cadmium plated. Would I do anything with this? Nah. It can be. The cadmium does shine up beautifully. It looks like chrome. You could polish this. It's just going to turn gray again. It'll take years, but it will again. And it's not that thick, and if you wear through it, then you're preventing the whole reason for it being there, which is to prevent corrosion. This is not rusty. I just leave it alone. Just leave it alone. I think that's it. Oh, one other thing. Let me flip this on its side. Which, of course, you also want to do very, very carefully. And also, use your best judgment. If we look at this dead on, if we're going to put this on its side, this does not go all the way to the edge. There's going to be a bit of a gap here. Put something under it to support some of that weight. It's going to fold up a cloth. Yeah. This will be enough. And put that down so the CRT is going to rest on that. Make sure I do this because I want to show you something underneath. We're going to put it over the edge of the workbench, tip it back. Not a bad idea. Support the CRT a little bit with your hand. And that's it. It's going to be like this the majority of the time we're working on it. Nice thing about these Admirals, everything is just right there, right out in the open. Another concern I get asked about a lot is, okay, I started working on a set. I've powered it up. I want to do some more work. I've turned it off. How long do I need to wait? What do I need to do to discharge the stuff under here? Generally, it's been my experience, if the set is showing some signs of life, in other words, the circuits are drawing some power, that main supply, the B+, dissipates in seconds when you turn the set off. You turn it on, all the tubes are lighting up, the plates are conducting, it's drawing power off of the supply, When you turn it off, as the tubes cool down, things start shutting down, they drain off that power off the capacitors. What I have seen where it can store a big charge for a long time is if you don't have everything hooked up, maybe there's a problem and there's not a big load on the main supply. Those big old can capacitors can hold quite a wallop, in which case, yeah, you can get a jolt. And certainly while the set is on, don't go poking around with your fingers. But generally, when the set is turned off, I just wait a few seconds and go right in there and start working on it. If you are at all concerned, check B plus with a meter. In fact, while you're powering this up and troubleshooting, you might want to just keep a meter clipped right on the B plus line. What is B plus? B plus is the main supply coming from our off-board power supply. Now in this case, we have two B plus. You can leave it as B plus plus and B plus. We have one that's 350 and another one that's 175 or something like that. Totally independent power supplies. Not a bad idea to check both of them if you can. Heat, yes. Tubes, especially the big power tubes, will get pretty darn hot. In fact, I've probably gotten more hurt from heat than anything else in working on sets. When I inadvertently brush against the hot tube and get a little bit of a burn. You're not going to get a 4th degree burn or anything like that, but they can get pretty darn toasty. Same with the power resistors. We have some down here. You should be able to sense it when you get near something that, oh, that's pretty darn hot, because things can stay hot for a while. Primary reason I go poking around is I have the set on, it's not quite working right, I want to swap a tube out. If it's something like a 5U4 rectifier tube, wait a good 10 minutes for that tube to cool down to avoid getting burned, or get a tube puller, which is an insulated type tool that is heat resistant and can yank a tube out. Or worst case scenario, wrap a towel around it and carefully extract the tube. Really, my main concern when I work on these sets, they're big, they're heavy. I've seen a lot of you guys post photos of your workbench, especially if you're working on radios, and you got a work area this big, which is fine for an All-American 5 or something. You get a TV like this with 2 separate chassis, you need quite a bit of space. My workbench is 8x3, and I still struggle at times to have enough space, especially because I put equipment on it, which shoot up a lot of space. But look at this. With this equipment and this is a 3-foot deep workbench. I'm right at the edge. Yeah, left to right I've got a fair amount of space, but just plan ahead. You need some decent space, especially when you're moving this around. You don't want to bump into anything or inadvertently cause any damage. And it's got to be able to handle some weight. You have a little folding card table, something like that. It might not be quite up to the challenge. But definitely when you're doing what I just did, where you're flipping it down, flipping it up, rotating it around, take it easy, take it slow, make sure you got enough clearance around. You don't want to whack something and break it. All right, let's talk about tools. Now, here are what I consider to be essential tools for working on a vintage TV. First, by far and away, a good multimeter. This will take care of the vast majority of our needs for testing and troubleshooting, double checking our work. I, like many others you'll see on YouTube, like the Fluke 27 FM for a few reasons. One, Fluke makes really good rugged meters. Two, this is the military version, so it's extra rugged. Three, they're dirt cheap because they're outdated. The government bought them by the truckloads, and they are now on the surplus market. You should be able to get a decent one with the case and all the accessories for less than $50. I have 3 or 4. I think I pay $25 each for them. They're good for up to 1,000 volts, 10 amps. They do AC/DC volts, AC/DC current, resistance, continuity, diode check. That's about it. You don't get any fancy new stuff. There's no backlight. There's no color display. It can't do frequency. Can't measure capacitance. We're not really likely to need to do any of that stuff. Voltage, resistance, continuity, that's what we're going to be mostly using this for. Highly recommend you get one of these guys. Battery lasts forever. I change it maybe every 2 or 3 years. It takes a 9-volt battery. You can leave this thing on for days. It won't drain the battery much at all. Next, just as if not more important than a good multimeter, is a good soldering station. If you're budget-minded, save up. This is where you want to spend your money because you're going to be using this a lot. We're going to be using this to replace every component in our device. I highly recommend you get a temperature-controlled iron. I like to use Weller. Others use Hacko. I've never used one, so I have no experience, but I know a lot of people swear by them. They seem to be very similar in cost and functions. What's the big deal about a temperature-controlled iron? Well, you dial in a temperature. I typically use 650, 700 Fahrenheit. This will sense the temperature of the tip and put more or less power into it to maintain that temperature. When you take your iron and you want to melt a big old connection on a chassis, this will pump more power into it and melt it. Basic irons that don't have any smarts to them, they don't have a temperature sensing tip, say you just get a 65 watt iron, you put it on a big joint, it just cools down. And you can't melt it, and you get very frustrated. Or you have to keep it on there a lot longer than you want to, which can damage the components going to it because the heat is going up the leads into the components. So, temperature controlled iron, highly recommended. In the past I used the WES51. This is the newer version. I forget exactly what it is. The WE1010. Yeah, I got it on Prime Day off of Amazon. It was $100 and change, something like that. Tips, I like to use the small chisel tip. Replacing the tips is very easy. You just do that and do that. The little holder they give you, you can hold your tips in there. Also have some conical tips. I find these aren't very useful for working on tube-based stuff with terminal strips. So the little small chisel tip I find works great. If you let this sit for a while and don't use it, it'll cool itself down to around 300 degrees or so, which is good because it saves the iron and the tip and all that. So leaving them really hot starts degrading the metal in the tip over time. But typically with one of these, geez, I have used the heck out of this tip for like the last, almost daily for hours. It's lasted me a year or two. So if you think the price is a little high, again, it gets back to, and you're going to hear this repeated over and over, how deep do you want to go into the hobby? If you're only going to work on this and never anything else, it might be a little hard to justify this. Maybe borrow one from a radio club or something like that. Otherwise, just be aware, you get what you pay for. I've used this meter for a decade or more. Just hours and hours, a day, day after day after day. Zero issues. I just had to replace the probes. That was it. Iron, used the heck out of it. I think I'm still on the original tip. Maybe I replaced it once. Now to go with your iron, of course, you're going to need some solder. I really like Kester number 44 rosin core, 6040 tin lead mixture. It's been around for forever. It's compatible with everything you're likely to encounter. No reason not to go with that. It's still widely available. Desoldering braid, and I also have a solder sucker around here somewhere. We may or may not use this. We'll get into soldering more as we actually work on it. There's other tips and tricks you can use to undo a connection than having to remove all the solder from it. Alright, let's move on to some tools. I mentioned this when I was taking the chassis out. This will become your best friend as 1/4-inch nut driver. Every fastener you see on this, just about all the ones that have a hexagonal head, they're all 1/4-inch. Also get yourself a flat-bladed screwdriver. You're probably not going to encounter any Phillips or any other type of fastener on this. They're all flat-bladed screws. Get a couple sizes, small and one a little bit larger than this, or just get yourself a tool that has changeable heads. This has Phillips and flathead, and a large and sort of a medium and a small, or sorry, medium and a large size. So I don't know that we'll need to, but if we wanted to adjust any of these, this is what we would use for that. Notice on the potentiometers we have some larger nuts there. Adjustable wrench should be good enough for those, or channel locks. So one of these guys, or these. Of course you could get a set of wrenches too, but I find it kind of a pain to dig through and find the exact size I need. Generally there aren't that many nuts and they aren't that hard to get out, so use something like this and get on there, go from the side. Or if you're so inclined, look around and find the right size wrench. I don't recall exactly what size these are. I think they're 1/2 inch. Don't quote me on that. Basic stuff. You guys probably already have a set of screwdrivers and wrenches anyways. My point being, they really don't need specialized tools for these. A flat-bladed screwdriver, a wrench, some nut drivers. That's really all you need in terms of hand tools. But for the wiring, basic wire strippers where you have a little, whatever you feel comfortable with. I like using these where they have predetermined sizes, or get the adjustable type. These are absolutely essential. Another tool, I just buy these a few at a time because I go through them so much. These are little diagonal side cutters. I get these from jewelry supply places mostly. This is the best pair I find. So many I've gotten where a jaw breaks off the side, or they get dull really fast. I'm trying to read, these are a bit worn out. I think it says CHP. CHP 170, made in Italy. I think I got these at Michael's in the jewelry section. And a pair of small needle nose pliers. These, this in conjunction with the soldering iron does like 90% of the work that I do. Absolutely essential. You need small stuff. Don't try using something like this. You will very, very quickly get frustrated. We need to work on terminal strips, tube sockets. We need small stuff. Especially invest some money in some small needle nose pliers. You use cheap ones, these tips are going to bend. You get cheap diagonal cutters, they're going to snap off at the end. I think that covers it. Other than if we need to get into some alignment or anything a little more exotic, this is going to pretty much do it in terms of hand tools. This and our soldering iron and our multimeter is going to get us really, really far in this project. One other bit of electronic test gear that is sort of a luxury, but boy, if you're going to work on more than one set, it's really nice to get something like this. This is a Sencor PR57. It's a combination variac isolation transformer, voltmeter, and current meter. You plug this into the wall, you plug the set you're working on into this. With this knob, you can control the AC voltage going into your device. You can monitor how much current it's drawing, and if it draws too much current, this will trip a circuit breaker. If the circuit breaker fails, it also has a backup fuse inside of it. Also, in some budget sets, one side of the AC line goes directly to the metal chassis, meaning there's a shock potential. This will protect you from that. Not the cheapest thing. There's also a PR570 that's really, really nice. They're both going to cost you a few $100, at least. You can make your own. You can get more budget-minded versions of it. Is it essential for this project? No, because this set has power transformers. It is not a hot chassis set. We could use a dim bulb tester, which will Also protected from drawing excess current, which is a light bulb in series with the power. So by all means, you don't need to have one of these, but especially to see how much current it's drawing and being able to slowly ramp up the voltage. Really nice things if you want to especially try powering it up before you've done any work on it, which is what we are going to be doing. Hey, what about all this stuff? We don't need it. You don't need it. I have it, and I will demonstrate using some of it. I highly, highly doubt we'll actually need any of it to get the set working reasonably well. An oscilloscope I'm going to break out so we can observe some waveforms and show you how some circuits operate and compare it to the service info. And a test pattern generator. You can get by without them. There's other less expensive ways to get around generating a signal to a view rather than getting this. But I will say this. TV equipment for the old analog stuff is dirt cheap now because only the weirdos like us want it, need it. So something like a Suncor VG91 when it was new was, I don't know, hundreds if not thousands of dollars. Now you can probably get one for $100. So it's just something to consider. Hey, what about a tube tester? What about a picture tube tester? Nice things to have, sure. Most of the tubes in this set are what you call less desirable. They're not used in guitar amps. So you could just buy them. If you go to the TV museum in Ohio, I think they sell tubes for $1 a piece. Ask around with other collectors. Something like a 6AL5, a 6AU6, a 6AG5. You should be able to get it for $1 or $2 each new. In other words, you don't have a tube tester, just put a new tube in there. But I'll also tell you, generally, it's not the tube. A lot of these sets were retired while they were still working simply because they're so early, people got better sets. Or when it stopped working, all the tubes didn't die at once. Maybe one tube failed. So the other tubes are all fine. So we're not going to worry about tubes too much now. But if we need to, we'll break out a tube tester. Testing the picture tube. Yeah, that one's a little bit dicier. Replacements, generally you can get them. It's a matter of how much do you want to spend. Figure $100, $75 to get a replacement picture tube, if you can locate one, depending on the type. Some are hundreds, some are a little less. This is a 12LP4, it's relatively common. But we're going to test it now because, well, it'd be nice to actually start learning something about this set. You can get a basic tester, B&K 440 or 445 is what I recommend to people because it's really easy to use. And they can be had generally for $20-$30. We are going to use a B&K 440 right now. It looks pretty early, but this is actually from the 60s, 62, 63, something like that. The reason I like it is for these early black and white sets, there's not much to configure with this. We have a big old meter here, some switches, 3 giant neon bulbs, 3 rotary switches, a couple push buttons. We're going to put G2 high, color gone. I never even use this for a color CRT. I leave it in the green position. Heater voltage 6.3. Virtually every picture tube you're ever going to encounter is going to be 6.3. This is your power switch. We'll leave that off. And have this fully counterclockwise for checking continuity and shorts. We can plug it in. Inside we have 2 umbilical cords. The giant one is for a color picture tube. We're going to deal with that. The other one fits right in the CRT. No adapters necessary. That's the other reason I like this. And remember, this is loose. Hold it firm. And put this on. I moved in closer and subdued the lighting because we're going to be looking for 2 things. One, a filament glow in the neck of the CRT, and the bulbs to light up. This has 3 bulbs. When it's working correctly, the 2 bulbs on the right light up. And each bulb has two sections, two half moons. We want the left half moon to be lit up on the two rightmost bulbs when we're in the continuity and shorts position. So here we go, turn on. Yep, filament is glowing, it's faint, and our neon bulbs are lighting up. Don't expect the filament to be super bright. I don't know if you guys can even see that. Just a little orange light down in there. But our bulbs are lighting up, that's good. If it was weak, really weak, those would be very dim, or it might take 5-10 minutes for them to come up at all. I'll put the light back on now so we can see the meter better. Now, when these have been sitting for decades without being used, the cathode can get a little tired, so to speak. I would let this run for a good 10, 15 minutes, 20 minutes before really evaluating the emission reading. But let's see what we get. Over to emissions. We're in the bad. But watch closely. It's slowly climbing a little bit. Let's flip over to cutoff. Cutoff varies the voltage on G1, which is how you modulate the intensity of the electron beam. If it's good, the needle moves when we rotate this knob. And there's one tick above 0. If you can rotate this knob and get it to the one tick above 0, well, it's in the good range on this indicator here, you have good cutoff. So, yeah, we're just at the edge of good. Go back and check our emissions. Obviously, we would like it to be good. A new one will test at around 800 or better. So we're quite a bit shy of that. This should produce an image because we can modulate the electron beam. We have some emissions. No, it will not be fantastic. I'm not surprised because it's the original picture tube by all indications. So imagine this was watched for a few years, many, many hundreds of hours. It's going to be a little worn out. But we are going to let this sit for a while. You can also accelerate the process a little bit. We have 6.3 volts on the filament right now. We can go up to 7. Notice the emissions are quickly going up. You can go to 8.4. That won't burn it out. Now if we go back to 6.3, it should be a little higher than it was. It's not. Alright. This picture tube's a little worn out. We'll let this sit. I'll come back in about 15 minutes and see where we're at. Well, after about 20 minutes, we're just into the green. So this will produce a decent picture, not a great picture. How long will it last? I couldn't say, but with moderate use, an hour a week should last for quite a while. This is a good reason to bring a picture tube tester with you when you evaluate a purchase. One, you can weed out a completely dead picture tube. Or if it tests really weak, you can use it as a negotiating point to get a better price on it. Could I rejuvenate it? Yeah, possibly. I'm not going to. If it was down near 0, I might give it a shot. I got nothing else to lose, because you can degrade the emissions even more. In fact, you're more likely to than to make it any better for any length of time. Could I use a brightener? Sure, but we're not there yet. It's on the edge of green. It'll work. Can I get a replacement for this type? Yeah, they show up now and then, $50 to $100. I could probably get a used 12 LP4 that was maybe just slightly better than this. New old stock, you're not going to find one, or very, very unlikely to. Rebuild, the last commercial rebuilder closed 14 years ago or so. You can't get them rebuilt. But even when you could, I got a very similar picture tube rebuild. It was over $300 when you factor in shipping. If somebody was doing it now, I'd expect it to be $500. Are you going to spend $500 to have a 10 or 12-inch black and white picture tube rebuilt? Probably not, because you could buy half a dozen more TVs with the same picture tube for that kind of money. So that's where we're at with the hobby today. 10, 20, 30 years from now, I expect the scenario to be a bit different. In other words, supply and demand. We're not at the point yet where picture tubes are scarce enough to really make rebuilding a thriving thing. And I'll tell you, there are a couple efforts to get rebuilding going. They're going to focus on the rare stuff. Early color, pre-war black and white, that kind of thing. 12 LP4s are not rare by any means. So, anyways, we're going to carry forward. In the next installment, we'll get that schematic back out, start poking around a little bit, and maybe we'll just try powering it up in a controlled manner and see what we can get. Thanks for watching.